Hi everyone, the purpose of this video is to help you review for the exam Unit 10 or Unit 10 exam, okay? So I am going to be pausing the video and writing things down to keep this video short. So if you need to pause, then pause as much as you need to. So number two, I'm going to do all the even problems. You guys will do the odds. So then I'm going to do number two, and notice this is asking us to solve by using substitution. So then that's what I'm going to do next. All right, so this is asking us to solve the system of equations. One is quadratic, which is the second equation. The shape of the graph is a parabola. And the second one, this first equation is a line because that's a linear equation. So we're trying to see if, determine if these two graphs intersect, okay? So to that end, using substitution, instead of y, here on the first equation is 2x minus 3. So then on the second equation, I'm going to substitute that y with 2x minus 3. And then I'm going to solve for x. So I'm going to subtract 2x, add 3. Subtract 2x, add 3. So then nothing here, so that means we have 0. So then this becomes x squared minus 4x plus 0, because these, the 3's cancel. So then factor a GCF of x. So this is x times x minus 4. So one solution is x equals 0. And for this one here, if I set x minus 4 equals 0, x equals 4. So far we have 0, comma, that's 1, and the other is 4, comma. So let's find the y values that go with these x values. So I'm going to go to this equation here and find the y value. So this is y equals 2 times, I'm going to use 0 first, and then minus 3, right? So then when you multiply 2 times 0, that's 0, so then what's left is negative 3. So then the y value when x is 0 is negative 3. Then I'm also going to use that value 4. So then for this one, y equals 2 times 4 minus 3. Well, we know that 2 times 4 is 8, and 8 minus 3 is 5. So then the y value that goes with 4 is 5. So then these are the coordinates of the points of intersection of these two graphs. So these are the solutions to the system. Okay, so let's move on to number 4. So number 4 is a long one. We've done lessons over this. I think I'm going to skip this one for the sake of time, but if you need me to help you with this one in class, I'll help you with it. Okay, but we've done 3 lessons over applications of quadratics. So let's go to number 6. And for number 6, this is simplifying, and notice we have complex numbers. Okay, so for this one here, I have a negative 1 implied in front of this parenthesis, which means this 7 becomes a negative 7, and this multiply negative 1 times negative 9, that becomes positive 9i. So then combine 16 minus 7, that's 9, and 18i plus 9i, that's 27i. And this is the answer to that problem. That's the simplest form. Number 8 next. Before I do anything else, I'm just going to notice that this is the square root of negative 4. So we know that's a complex number or imaginary number. So that's equal to 2i because of this minus in front of it. And square root of negative 100 is 10i. So then I have negative 5 here minus 2i. There's a plus in between. And then this is a 3. And this is minus, so minus 10i. Then since this is addition, I'm looking at negative 5 and 3. Combine them together, I end up with negative 2 and negative 2i minus 10i. That's negative 12i. So this is the answer to that problem. So let's move on to number 10. For number 10, we're multiplying. Okay, so then this is 4 times 4, which is 16. 4 times negative I, that's negative 4i. 5i times 4, that's plus 20i. And then 5i times negative I, that's negative 5 times I squared. So then this is, don't forget this one here becomes negative 5 times negative 1, because I squared is negative 1, right? So then we have negative 5 times negative 1 is positive 5. When I combine 16 and 5, they combine to 21. Negative 4i plus 20i. They combine to positive 16i, and this is the answer to number 10. All right, let's see what else. Number 12. So for this one, we have a complex number in the denominator. We can't have complex numbers in the denominator. So I'm going to multiply by the conjugate of 4i, 4 plus I, which is 4 minus I, and multiply that numerator and denominator. So I'm going to multiply this across, but I'm going to pause the video, and I hope you understand what I'm doing here. Well, let me just do it. So 7 times 4, that's 28. 7 times I, that's negative 7i. Then negative 2i times 4, that's negative 8i. And negative 2i times negative I, positive 2i squared, over 4 times 4, that's 16. 4 times negative I, negative 4i. I times 4 plus 4i. And negative I times negative I, that's negative I squared. But then don't forget that I squared is equal to negative 1. So 2 times negative 1 is negative 2. And then negative I, the I is negative 1. So negative times a negative becomes positive. So keep this in mind. And these 4 i's and these 4 i's, negative and positive, cancel out. So then I have 28 minus 2, that's 26. 7i minus 8i, that's minus 15i, over, let's see, 16 plus 1, that's 17. So this is the answer to number 12. All right, number 14. Again, we need a conjugate to this one. So then multiply numerator and denominator by 9 plus I, over 9 plus I. So then 5 times 9 is 45. 5 times I is plus 5i, over, let's see, 9 times 9 is 81. And 9 times I, that's plus 9i. Negative I times 9, that's negative 9i. And then negative I times I, that's negative I squared. So then we have 45 plus 5i. Don't forget the 9i's cancel. This becomes negative times negative 1, so that equals positive 1. And we're adding not 1 plus 81, so that's 82. And this cannot be simplified. Okay, and that's the answer to that problem. Okay, number 16. Number 16 is review. So for this one, the vertex is at 1, 4. So then write 1 up, 1, 2, 3, 4. Plot a point here. Since we have a negative value in front of it, the parabola should be opening down. So if I go left 1, down 1/2. If I go left 1, 2, I should be going down 4. But we take half of that 4 and go down 1 and 2. If I go right 1, down 1/2. If I go right 2, down 4. And then connect the points. And this is what that graph looks like for this quadratic function. Okay. All right, number 18. Number 18, we're being asked to factor completely. So I noticed that there's a GCF in 8, 30, and 50, and that GCF is 2, because 2 goes into 8, 30, and 50. So then I'm going to factor it out. So then this becomes 4x squared minus 15x minus 25. So notice a is 4. So then I have to use factor by grouping here. So I'm going to multiply 4 times negative 25, which is negative 100. And I need to find the multiples of negative 100 that when we add them, give me a negative 15. So the only multiples that do this are 5 times 20, and the 20 should be negative, right? Because we need a negative 15 when we add them and negative 100 when we multiply them. So then to that end, I'm going to say 2 times 4x squared. I'm going to put the negative 20x with the 4x squared, and plus 5x goes with the negative 25. Okay, so then GCF here is 4x. GCF of this group is 5. So then I'm not going to lose that 2. So we have 4x times x minus 5, because negative 20 divided by 4 is negative 5, plus 5x, negative 25 divided by 5 is also 5. So then I'm going to come here, and I'm going to notice that I have x minus 5 and x minus 5, so I'm going to factor that out, and then put together 4x plus 5 in another parentheses. Okay, and this is factored completely. All right, next problem. So for this one, we're being asked to solve using the quadratic formula. So I'm going to jump this 2 to the other side, meaning now the equation becomes 7x squared minus x plus 2 equals 0. And quadratic formula is this. Opposite sign of b plus or minus square root of b squared minus 4 times a times c divided by 2 times a. So this is a, b is -1, and c is 2. So then x equals, let's see, b is -1, so +1, change the sign, that's what the formula says, plus or minus square root of b is -1 squared minus 4 times a is in this case 7, and c is 2. And then all of this divided by 2 times 7, right? So then 2 times 7. So I am going to do this on the calculator, the discriminant, not the whole thing. Okay, so let me show you what I'm saying. So let's see for this one here. I'm going to do the discriminant for the sake of time. -1 squared minus 2. Let's see, minus 4. Minus 4 times a, which is 7, times c, which is 2, it gives me -55, right? So then this is equal to 1 plus or minus the square root of -55 over 2 times 7, which is 14. Well, 55 is not prime, but the only multiples of 55 are 5 times 11. 5 is prime and 11 is prime. Since this is negative, we could factor out I from here, right? So this is, let me just write it here, -55. I can separate -1 times 55. And then I just said you can't do anything with the 55, so I'm just going to factor out or take out I from the square root. So then the solutions are x equals 1 plus or minus I square root of 55 over 14, and these are the solutions to this quadratic equation. So both of the solutions are complex. All right, I'll see you in the classroom. Thank you for watching. Bye-bye.